All right, so this is our second lecture on chapter 14. And then what we're going to do now is look at more of the chemical hazards. Like mercury was a chemical hazard. What we want to do is, again, what is a toxic chemical? It's something that either temporarily or permanently causes injury or death. And so we have three types that we definitely want you to know. So be able to tell the difference between the three. And you can see those. Carcinogens are viruses, radiation chemicals that actually cause cancer. Mutagens are things that actually increase genetic mutations, so they're changing DNA. And then tetragens, which are the worst of the three, well, they're all bad. I don't know, worst is probably a good idea to mention, but tetragens, which are actually causing birth defects, which is what you see on the right in that picture. So all three of these are, again, not great, but we want you to know the difference between the terms. All right, so how do they affect us? And there's really two major types. One is neurotoxins, and they affect the nervous system. A lot of pesticides will do that, where they cause twitching and brain damage, things like that. And then we have the second one that is the endocrine disruptors. Endocrine system is one associated with hormones. These secrete hormones into the body. And so we do want you to know the term HAA and what that stands for. So HAA, it's in the study guide, those are hormonally active agents, and they work in one of two ways. They can be hormone blockers. So in other words, maybe we're releasing testosterone, but testosterone is not being picked up by receptors because one of these HAAs is sitting there attached to the receptor and blocking it. Another one could be a hormone mimic, where it actually attaches to the receptor, but in this time, instead of blocking it, what it does is it pretends it is that hormone and can cause all kinds of problems because now you are reacting to way too much of that hormone. So all of these have become extremely important for us to understand. And there's lots of examples, and we'll talk about some of them a little bit more, but BPA is one of the things on the study guide, and I've got slides for that, so we'll slide by that for now. Teflon and flame retardants. Teflon is the brand name of the nonstick pans. And so we use those, lots of people use those, but that could be an issue. And I know for a fact is they say you don't use them around birds, that there are a lot more receptive to that. And so you want to be very, very careful. And then we have phthalates, which make plastic flexible and flexible tubing, things like that. And then PVC, which we use for water. But then we also use for other things to harden plastics. All right, so BPA, let's talk about that. It's actually an estrogen mimic. It is a hardening agent for plastics, and it gives you those hard plastic bottles. Plastic containers, water bottles, so some of the water bottles you use, that's why I showed you like a hydro flask instead. Which is metal. It's funny if you want to buy something American, I've noticed that all of the hydro flasks are made in China, and the metal is, again, toxic. I'm sure the smelting process for that is not great, but it's a one-time deal and they're long-lasting and it doesn't seep into your food. Soda cans, food cans are lined with BPA. And even thermal cell receipts, the one that heated onto the paper, if you are handling that when it's handed to you, that can give you BPA. 93% of Americans age 6 and older have traces of BPA in their urine. 93%. That means that it's just massively around every place. And children and adolescents generally have a higher BPA level than adults, especially if you're putting it directly in their mouth. If you drink from a polycarbonate bottle regularly for 1 week, 66% will see an increase. So you need to make sure you get rid of those bottles. Do not use them. Especially don't use them on kids. There are plastic bottles out there that are marked BPA free. It's pretty subtle. You have to look for it. Sparkless bottles, Arrowhead bottles There used to be, and still are, because it's expensive, many of those are not BPA free. But you can go to a water store if that's what you want, if you do not have good water coming to your house. And those water stores will sell you a BPA free bottle. So anyway, it is an estrogen mimic, and hopefully you will watch the troubled waters video, and we'll talk about that more. All right, toxicity dose and why children are more affected. I want you to know what the term toxicity is. It's just a measure to see how much something can cause injury or death. Dosage is how it's being, ingested. It's how much. And there's some controversy on that. We need to find out ways of dealing with how much are you getting, what is safe. And we find out children are more affected is they breathe more air. They're smaller, but relative size. They take in more water, they take in more air, take in more food per body size, which means that their cells are getting higher doses of everything, and unfortunately things like BPA and toxins. And they're exposed more. They're closer to the ground, and they put everything in their mouth. And so there's another issue there. And then the third is their immune systems are less. Actually, kids are really born with a poorer immune system. Antibodies and stuff that babies have are typically from mom. It's a passive immunity. And then the immunity has to kick in. They have to be exposed to things. And their body does not get rid of things as well as our kidneys and livers do as adults. So those are really the three reasons why children are more infected. All right, and then there are two different ideas. One is chronic toxicity, and how much you can put in on a daily basis without any concern. It's going to build up. And then there's acute toxicity, where if you take this amount, boom, you're dead. So we have two different levels, and you can see some of the things. And we have numbers. And again, I'm not going to test you on any of these really. But what's always amazing to me, how much table sugar you can take. If you look at some of these ethanol, that's alcohol. How much you can actually have alcohol poisoning. I know a person that drank. He was an alcoholic. And basically he went to a hospital, and they said that he would be dead if he didn't stop drinking. His face had turned red, his body, his liver and kidneys just could not get rid of the toxins fast enough. And things you can see on the left-hand side, things you use, caffeine, there is a toxicity level, and nicotine, there is a toxicity. The rhodinone, that is actually we use that in rat poison. It's organic pesticide. And so anyway, and then you can see the acute ethanol over here. There is a number that'll kill you. You can binge drink and actually die from that. So there's all kinds of different things. So I do want you to know the difference between chronic and acute. And again, nothing on the chart I'm going to hold you to. All right, and then let's talk about the dose response curve. If you see on the right, there are three different curves. One is a non-threshold, so there's no safe amount. When you start taking it, what happens is the more you get, the more of the effect. And then you have what's called a threshold level. So there seems to be a threshold that if you take less of, it doesn't really affect you. But once you get to a certain amount, then you start having issues. And then we have some that are just off the map and then all of a sudden when you get a major amount, it's actually better for you. I'm not sure I would test that out, but that's kind of the idea behind this. And I want you to know what LD50 stands for. So LD50, LD is lethal dose. So these are usually animal studies where they are giving an animal a certain amount of dose, and what is the dosage that kills half of them. Now we're assuming that translates to humans, and humans and different animals are different. So I'm not sure we can really say that, but they're doing it based on body weight. So whatever the dose is for a mouse, you just take that ratio to a human, and then that would be our lethal dose that half could. So this is something they calculate all the time. And so we'll end it there with LD50, and in our next video we'll talk about some of the consequences. So we will stop.